In this section, we're going to talk about 12.4 angle measures and secant lines. And a secant line is a line that goes through a circle. So it's somewhat similar to a chord, except the ends go on forever and ever. So we'll just call this line AB. So let's take a look at some properties that secant lines have. And the first one that we're going to take a look at is the intersection of two secant lines within a circle. So here in number 1 you see that we do have two secant lines and they intersect, and we're going to try to find the measure of angle 1. And one way to do it is you want to look for the arcs that intercept that angle. For example, this is an intercepted arc of angle 1. So we'll just call that X. And over here, since these are vertical angles, this would also be considered angle 1. And so we'll label this arc as Y, since that's technically considered an intercepted arc as well. So the way that we find the measure of angle 1 is we typically just take half the measure of the arc, but this time we have to take half the measure of the sum of those two arcs, since it's being created by both of them, just like that. So that's the first property that we're going to take a look at. The next one that we're going to take a look at is when the intersected angle is outside of the circle. So here's where those two secant lines will intersect, and it's outside of the circle. So it has a little bit of a different property here. So we still want to take a look at the two arcs that that angle intercepts. This one being the first one, since it's an intercepted arc, and then the next one being this one over here, which is closer to the angle. And when this happens, all we need to do to find the measure of angle 1 is we're going to do 1/2 again, but this time it's going to be the difference between X and Y, since the angle is outside of the circle. So let's take a look at a couple examples. So here we have an example, and we have the intersection of these two secant lines inside the circle, and so we are going to solve for X by following the formula. So the measure of X is going to be equal to 1/2 times the sum of the intercepted arcs. So that would be 46 and 90. And therefore, X is going to be equal to, let's see, 68 degrees. Just like that. And now let's take a look at this example. This is with the intersection of the secant lines outside of the circle. And so we know that the measure of the angle that we're dealing with, which in this case is 20, is going to be equal to half the measure of the difference of the two. So I'm going to write 95 minus Z. Okay, so we have to go ahead and solve this. So I'm going to cancel out the 1/2 first by multiplying both sides by 2. So that gives me 40 equals 95 minus Z. And I'm going to go ahead and subtract 95 from both sides. And that is going to give me 55, negative 55 I should say. And that's equal to negative Z, so now we just have to switch the signs, and Z is equal to 55 degrees, just like that. And we're just going to take a look at a few more properties of secant lines. And the first one being, if we once again have the intersection of our secant lines within the circle, we can say something about the lengths of those secant lines. And one thing that we are going to learn is that the product of A and B, whatever those lengths may be, is going to be equal to the product of C times D. And another one of our properties is this is for secant lines that intersect outside of the circle. So if I could split each of those secant lines in two pieces created by the circumference of the circle, I could say once again that the product of those secant lines is equal to the other, but this time it's a little bit different. Because our intersection is outside of the circle, what we're going to do this time is we are going to get the total length of each of our secant lines, which for the blue line, I'd have to add x and w together. But once I do that, then I multiply that by the length that is outside of that circle, which for the blue line would be w. And that is going to be equal to the same concept for the red line. So the sum of each of those pieces individually, and then multiplied by the length that is outside the circle. Okay. And the last case that we're going to have is the intersection of a tangent line and a secant line outside of a circle. So notice that the blue line there is a tangent line. It intersects my circle right about here, and then I've got my secant line which intersects the circle here and here. So this works very similarly to the second property that we just looked at. We still have to add, for the red line here, we still have to add those lengths together to get the entire length of that secant line. And once again, we're going to multiply that by the part of that that lies outside the circle. So that part hasn't changed. But now what do we do with the secant part? And this part's really easy. And it's simply equal to that length squared. That's it. So let's take a look at a couple quick examples so we can see how to use these. Okay, so in each of these, we are going to solve for the missing variable. So the first part of example 2, this is two secant lines intersected outside of the circle. So this is where we're going to add the lengths of both and multiply by the side that's outside of the circle. So for the first line, let's go ahead and do 8 plus 6, and then the part that lies outside the circle is 6 as well. And we're going to set that equal to the sum of the other two lengths, y plus 7, times the length that lies outside the circle, which is also 7. All right, so let's start simplifying. So 8 plus 6 is 14. And now we have to distribute. So 7 times y is 7y, and 7 times 7 is 49. And 14 times 6 is going to be 84. So now it's just a matter of reducing all of this. So minus 49, which is going to leave me with 35. And 7 fits into 35 5 times. So there we go. Now, on the second problem, we have a tangent line and a secant line intersecting outside of the circle. So in this case, I'm going to take the sum of the secant line segments, so that would be 16 and 8, and I'm going to multiply that sum by the value that's outside of the circle, which is 8, and that's going to be equal to the tangent line's length squared, so z squared. So 16 times 8 is 192, and we're going to multiply that by 8. And I'm sorry, I just realized that 16 plus 8 is not 192. 16 plus 8 is going to be 24. So when we do 24 times 8, that gives us 192. Okay, and then we take the square root of both sides, and that's going to give us about 13.9. So that's what we're going to be doing in this section, and that concludes this tutorial.